Alright, so in this video I'm going to be going over the Chapter 3 and 6 test review. On the first one, it wants me to state the domain and range of the following graphs. So on this first one, I am starting at this one is -3, and it's got a closed circle, so I want to use the square bracket. And it goes all the way over to here, which is 5. It's got an open circle, so I want to make sure I use my parentheses. For my range, my lowest value is 2, and it has the open circle, so I use parentheses. My highest value is 10, and it's got a closed circle, so I want to use the square brackets. On B, my domain, my lowest value is 0, and it has an open circle, so I use a parentheses. My highest value is 7, and it's got a closed circle, so I use the square bracket. For my range, my lowest value is -5, and it has an open circle, so I want to use parentheses. My highest y value is 2, so I want to use a square bracket. On C, my domain, my lowest value is -10, -9, my bad, and it's got a closed circle, so I use a square bracket. And then my highest value is 4, again with a closed bracket, so closed circle, so I use a bracket. For my range, my lowest y value here is -3. And because it's a line and not a point, I want to use the square bracket. My highest value up here is 8. And again, square bracket. Number 2 wants me to find each of the following given this function. When I have equals 13, this means set it equal. So I'm going to set my equation equal. I'm going to have 13 equals -3x plus 4. Then I want to subtract 4. I get 9 equals -3x. I want to go ahead and divide both sides by -3. I get x equals -3. In parentheses means plug it in. So this one I'm going to be plugging in 5. So I'm going to have f of 5 equals -3 times 5 plus 4. Then I just want to focus on my right side of the equation. The left side is just reminding me what I plugged in. -3 times 5 is -15 plus 4. And then -15 plus 4 is -11. C is another equals 2, so I want to set it equal. I have -38 equals -3x plus 4. Then I want to subtract 4 on both sides. I get -42 equals -3x. And I can divide both sides by -3. This is going to give me 14 for my final answer. Okay, number 3 wants me to simplify each expression. So I want to get rid of negative exponents. This is the same thing as 12x cubed times 1 over y to the 8th, because remember negative exponents turn it into a fraction. Then I just multiply all the way across, so I'm going to have 12x cubed over y to the 8th. Next one, same idea. I have 73 times 1 over d to the 9 times f to the 5. Multiply across, I'm going to have 73 f to the 5 over d to the 9. Next one, I have 123 times 1 over q to the 4th times 1 over r squared. Multiply across, so I'm going to have 123 over q to the 4th r squared. Okay. Number 4, again, wants me to simplify my expressions, but this time I have to use my power rule. So I want to distribute my exponent in. So everything in this first one is going to get an exponent of 2, so it's going to be 2 squared, a squared, and then for the b, I multiply, so 4 times 2 is 8. And then the next one I get a to the 5th, b to the 5th, because they each get that exponent of 5. 2 squared is 4. Then I want to add my exponents for my a's. So 2 plus 5 is 7. And then for my b's, I add again. 8 plus 5 is 13. Same idea on b, so I want to distribute. That's going to be 8 cubed, m cubed, n to the 15, and then m squared, n squared. I don't know what 8 cubed is. So 8 cubed is, oops, that's in the light, 512. Then I have my exponents on my m I want to add. 3 plus 2 is 5. 15 plus 2 is 7. Same idea on C. So I have 4 to the 4th. That's going to be j to the 8, k to the 12th. Then I have j to the 15, k to the 5. Then I don't know 4 to the 4th power. It's 256. Then I want to add my exponents on j. 8 plus 15 is 23. And then on k, 12 plus 5 is 17. 5 wants me to simplify these fraction ones. Remember, with fractions, I can rewrite it as subtraction. So I have b is 6 minus b to the 6 minus 8, which is going to be b to the negative 2. And since it's a negative exponent, I want to rewrite it as 1 over b squared. Same thing for b. I'm going to do 7 minus 3, which is h to the 4th. It's a positive exponent, so it stays as it is. C, I want to subtract. So I'm going to have t to the 5th minus 2. And then, because I look at these in two separate parts, it's going to be u to the 4 minus 9. So 5 minus 2 is 3, and 4 minus 9 is negative 5. I rewrite this as t cubed times 1 over u to the 5th. And then I just multiply out, so I get t cubed over u to the 5th. Okay. Moving on. On this one, my negative 9 stays the same. My x to the negative 8 gets rewritten as 1 over x to the 8. And y to the 0 turns into 1. Then I multiply across. This gives me negative 9 over x to the 8. Same thing for b. I have my negative 12. V to the 0 turns to 1. And then w to the negative 3 turns into 1 over w cubed. I multiply across. This is negative 12 over w cubed. Then I have negative 7 times 1 over c squared. And then the d turns into 1 because of the 0 exponent. I have negative 7 over c squared when I multiply across. Okay. Number 7 wants me to find the indicated nth roots of a. So on this first one I have n equals 3, a equals 125. So I have the cube root of 125. I can either do this by hand if I know it, or I can go to math, choice 4, and then type in 125. Which gives me 5. On B, this is just regular square root of 64, which is going to give me plus or minus 8. I have two answers when n is even. Oops, I did not mean to put this one. Okay, the last one I have is the cube root of negative 512. So again, this one I'm going to type in the calculator. Math 4, negative 512, which gives me negative 8. Eight gives me a function. It wants me to find the following. A wants me to set it equal to negative 2. So I'm going to have negative 2 equals negative 3 times 0.25. To the x. For this one, since it's an exponential, I'm going to just graph this. So I'm going to have negative 2 and then negative 3 times 0.25 to the x. And then I go ahead and graph those. I'm looking for where they cross at. So I'm going to go second calc, and then I'm going to go 5 for intersect. I press enter for my blue line, enter for my red line, enter one more time, and this one tells me 0.29. On B, I want to plug in 1, so I have f of 1 equals negative 3 times 0.25 to the first power. This one I can just straight type in over here. So I have negative 3 times 0.25 to the first power gets me negative 0.75. Same thing for C. I'm going to have f of negative 4 equals negative 3 times 0.25 to the negative 4. typing that one in, I get negative 768. Okay. This one wants me to decide if it's exponential growth or decay, and then the percent rate of change. This one, the number inside is larger than 1. It's growth. So then I want to do 1.4 minus 1, which gives me 0.40, which I multiply by 100 to get 40%. On B, this one is less than 1, so it's decay. So I do 1 minus 0.59, which gets me 0.41, times 100 is 41%. This one again is also less than 1, so it's decay. I have 1 minus 0.99, which gives me 0.01, times 100 to turn it back into a percent is 1%. Number 10 wants me to solve these equations. I take my exponents and I set them equal to each other. So I'm going to have 5x minus 3 equals 7x plus 9. Then I just want to add my 3, so I have 5x equals 7x plus 12. Subtract my 7x. I have negative 2x equals 12. Divide both sides by negative 2. X equals negative 6. Same thing for b over here. So I have negative 2x plus 7 equals 5x plus 14. I'm going to add the 2x to both sides. I have 7 equals 7x plus 4. Subtract the 4. I get 3 equals 7x. Divide both sides by 7. My answer is just x equals 3/7. I'll leave that one as a fraction since it doesn't simplify nicely. And then my last one, I want to take those. I have x minus 1 equals negative x plus 5. I'm going to add this x over so I have positive x's. So I have 2x minus 1 equals 5. Add 1 to both sides. 2x equals 6. Divide both sides by 2. X equals 3. And then the last thing on this page says anything other than 0 raised to the power of 0 is always 1. That's an important thing to remember. Okay, so on 11, it wants me to solve the following for each situation. It wants me to find if it's growth and decay, my growth and decay factor, and then the function that models the situation. This is going to be in the form y equals a times b to the t exponent. A says an initial investment started out as $12,175, and then after 1 year it was worth $13,500. This is my initial amount. This is what I end with. 1 year is my time. So I'm just going to label those right now. It's asking if it's growth or decay. It gets larger, so this is growth. To find my growth factor, I need to plug into the equation and solve. So I'm going to have 13,500 equals 12,175 times b to the first power. I just rewrite this as 13,500 equals 12,175b. I want to isolate my b, so I'm going to divide both sides by 12,175. Then I want to go ahead and type this into my calculator, which I'm going to round to 2 decimal places. Is going to be 1.11. So that's my growth factor. Then to write my equation that models the situation, I plug back in a and b. So I have y equals 12,175, and then in parentheses 1.11, and t as my exponent. So same thing on b. It says I purchased my car for $19,000. That's my a. After 1 year, that's my time. The dealership valued the car for $17,250. This is my y. This one is getting smaller, so it's decay. Then to find my growth or decay factor, I plug in. So I have 17,250 equals 19,000 b to the first power. I can rewrite this without the exponent on the b. Then I want to divide both sides by 19,000. Which gets me 0.91. So my growth factor is 0.91. To write my equation, this is going to be y equals 19,000, and then in parentheses 0.91 to the t power. C says a small town has a population of 1,100 people. That's my initial amount. After 1 year, so my time is 1, their new population is 1,523. So I'm going to type this, or not type this, plug this in. So I have 1,523 equals 1,100 times b to the first power. I can rewrite this without my exponent. So I have 1,523 equals 1,100 times b. Then I want to divide both sides by 1,100. So I get 1.38 for my b. So this is getting larger. It's a growth. And then my growth factor is 1.38. Plugging into the equation, I have y equals 1,100 times 1.38 to the t power. Number 12 wants me to decide whether it represents an exponential or linear function. On my first table, my y values are multiplying by 2. Nope, not multiplying by 2. That second one to go from 4 to 6 is adding 2. So because it's not a multiplying or dividing pattern, this is not exponential. So then I need to check to see if it's linear. So I add 2, add 2, add 2. This one is linear because it has an adding or subtracting pattern. So exponential is multiplying or divide. Linear is add or subtract. So on this next one, to go from 2 to 10, I multiply by 5. 10 to 50 is times 5. 50 to 250 is times 5. This one is exponential. Now my last one, I can divide by 3, and divide by 3. So this one again is exponential.